Hello everyone and welcome to the ATRA webinar. My name is Mike Souza. I will be presenting the 62TE update. Basically we're going to be covering some of the differences between the 41TE and the 62TE. First thing I'd like to do is after I welcome everyone to the presentation, the Seal Aftermarket Products is sponsoring this webinar as well as several other webinars that we're doing. I want to especially thank them for this. This allows everyone to actually attend our webinars for free. It doesn't matter if you're a member or non-member of ATRA. Seal Aftermarket Products and also Transtech will be sponsoring several of our webinars. If you have any questions or comments, please send the emails to webinars@atra.com and someone there will contact you and address any questions or comments you have. If you have any questions that you may have during the seminar, feel free to go ahead and text them in. If I see the question come up, I'll stop and try to answer the question for you. Why 6 speeds? Well, the 62T is got several advantages over a 4-speed. Obviously, by having the additional ratios and a quicker shift, it'll allow the engine to stay within the optimum efficiency and save fuel. As you can see between these two blue lines, that's where the optimum engine efficiency is at. On the left, you can see the engine RPM, and as it rises, if you look at the dotted red line for the 4-speed, you can see the engine RPMs kind of wind out pretty good before the 1-2 shift. And the same thing is you can see here on the 2-3 and then on the 3-4. So if we can get that shift pattern quicker and more often, we can keep the engine RPM down and save fuel. This works pretty much like a CVT. The same idea behind the CVT is to keep the engine RPM down as you go through the different ratios. Okay, I have someone saying they have no audio. You may want to turn your volume up. Is anyone else having a problem with the audio? Make sure the volume is not muted on your computer. If anyone else is having a problem with the audio, please text me and let me know. If you can hear the audio, someone please text in and let me know if the audio sounds okay. Thank you, Mara. Appreciate that. Marvin, I can hear me okay, so apparently there must just be an issue on Jerry's computer. Okay. Okay, back to the webinar. 62T, even though Chrysler says it's their new generation front-wheel drive or an all-wheel drive version of it, it has been out since 2007, so the concept's been, it's already 7 years old. The concept is actually of this transmission has been taken from the 41TE. Chrysler felt that was a pretty reliable transmission, so off the 4-speed they've developed this 6-speed. Basically what they've done is they split the final drive to whether it's either going to be underdriven or direct drive. So that's how they can have a double ratio on the final drive. Now, although this does classify it as a 6-speed, there are actually 7 forward speeds on this transmission. The 4th gear prime that you see here, that ratio is only used during a 6/4 downshift. Now, the reason that they have that separate 4th gear prime ratio is they don't want to have an issue at that speed and at that engine torque to try to kick down when you have to have 2 components coming off and 2 components coming on. So that's normally how they run the other upshifts, and you'll see that as we go along. But during the 6/4 kickdown, they'll use a 4th gear prime. And we'll kind of take you through that power flow later on in the presentation. One of the important things you want to do is this ID tag that you see here. If you're ordering parts for this transmission, you want to make sure you're getting the right stuff for the model that you're working on. So this matrix tag that you see here on top of the bell housing. If it becomes damaged or missing or anything like that, especially after it's gone through the parts washer, you can see that this PK number that's listed right here, that's also stamped in the back of the case right here in this corner. So if we lose the tag, we still have the PK number, and you should still be able to order anything you need for it or identify the transmission you're working on. Obviously, this doesn't count if somebody's been inside and changed things around, or if it's a core that someone's been into. You're going to have to be careful when you're dealing with parts on those. One of the first things we notice on the outside of the transmission is we have 3 speed sensors now instead of the 2 that we're used to seeing on the 41 TE. And as you can see, we've added a side cover, and the valve body's been moved over to the side of the transmission. So the input speed sensor is still located right here on the top of the transmission, has been relocated there. It still continues to read turbine speed just like the 41 TE did off the input clutch hub. Now you have a TSS, which is actually an output speed that's been relocated to the back of the case, and that's right over here. And that's the actual transfer shaft speed sensor. Now notice we have, what's unique to this transmission, we now have a separate output speed sensor located right near it. That's the OSS. Now what you want to do is you want to be careful we don't cross these 2 connections right here. They're very close together, and the connectors are the same, so it wouldn't be a problem to actually swap those by mistake. So if you do that, just be careful because you'll be chasing ratio codes and maybe erratic shift problems. You may think you have a valve body or solenoid issue, but you actually, if you cross those speed sensors, you're going to have a problem there. The case connector is kind of unique on this. There's 2 different color pins on it. The actual, like a gold color pin is for the pressure switches. All the other pins that are like a tin or a silver color are actually for the solenoids. Here's the pressure switch status for the 62 TE. We have 6 gears here. We also have 4th prime. Now, I apologize, this is not in your handout. If you're a member of ATRA and you actually want to download this handout of this chart for the CVIs, you can go to the ATRA website and go to the repair center and just type in 62 TE CVI in the search box, and it'll pop right up. It's also, I believe, on page 156 of our 2012 ATRA seminar book. Now, if you're a non-member and you want to take a moment to write these down, that's fine. If it takes too long, obviously, I'll pull this slide back up at the end of the presentation if you want to do that. One of the other things that one of the techs out in the field actually suggested was just hit the print screen key on your computer. Now you can just open up a blank Word document and right-click and paste it there, and you can have this chart right there on your in Microsoft Word. So if you want to go ahead and hit print screen, and I'll keep moving along with the webinar. Okay, I see Jerry's changed computers, so he's up and running now. That's good. Other changes between the 41 to the 62 TE is you'll notice that the solenoid block or body looks very similar to an RFE, especially with the 23-way connector. So that's the first thing you're going to notice there. Now, we've added a TCC solenoid, which they refer to as the EMCC. It's a variable force solenoid. It's electronically modulated converter clutch. And then we also have another solenoid down here on the right, as you can see, the line pressure solenoid. That's variable force solenoid also. And as well as the line pressure solenoid, we also have a line pressure sensor or transducer. So this is pretty much similar to like what they've used on the earlier 41 TEs, the later 41 TEs before the 62 TE came out, where they have a line pressure solenoid reduction. It lowers line pressure on those units, and you have the transducer to report that information back to the TCM. One other thing you'll notice here is you've got a new trans range sensor. And you see that there at the bottom of the diagram. So these are all the differences and changes between the 41 to the 62 TE. Other changes you're going to notice will be in the valve body itself. There's the addition of a low clutch switch valve and a new blocker valve, or otherwise referred to as the direct clutch switch valve. This switch valve prevents the direct clutch and the low clutch coming on together during application and release when it's upshifting and downshifting. So that valve was added to the valve body. Other changes in the valve body area you'll notice is these 9 check balls actually used for plugs. These check balls are not removable. They're actually in there for like special tooling that can go through the side cover to do pressure checks. So you don't remove those from the valve body. Later on, Chrysler actually removed these plugs. Obviously, they did it for the biggest reason they did it was to save money, having to put those in there, and also for future possible leaks in that area. So they've eliminated all those 9 check balls. And the ones that I'm talking about is the ones with the P by them. These are the ones that are actually used as plugs. We still have an overdrive check ball, underdrive, reverse, and low reverse check ball. There's 4 check balls in there. Some models that you may run across, the underdrive check ball may be missing. If that check ball is missing, if you put the separator plate across this casting, you'll notice that there's no hole drilled for the check ball. So the bottom line is, if you just want to cover yourself, if you put all 4 check balls in and it doesn't take the check ball, it wouldn't matter because the plate's blocked off anyways. So that's not a problem there. You just don't want to leave the ball out if there is a hole in the separator plate placed right over that check ball area. Once we take the valve body off, you're going to notice these 3 tubes. These tubes actually feed oil to the underdrive compounder assembly. Notice the O-rings on the 3 tubes. There's O-rings on both ends. You want to be careful here because if we obviously have a leak issue with these tubes, it could cause some damage to the compounder. So make sure you put plenty of assembly lube on those, and just be careful when you actually put the tubes back in. Okay, like I was saying before, the 6-speed is basically a 41 TE with some additional components added to it, referred to as the underdrive compound assembly. As you can see here at the top of the diagram, this is the same as a 41 TE, so the main case parts really didn't change. Now over here on the differential side where the transfer shaft is in the differential, this is the underdrive compounder assembly. They've added a direct clutch here, and they've also added a low clutch and a sprag. We didn't have a sprag before on the 41 TEs. And you'll also find in the same area there'll be a planetary set. Now, like I was saying before, the underdrive compounder works in 2 modes, either direct or in reduction. So the 2-3, the 3-2, and the 4-2 shifts require a double swap shift. And I kind of mentioned that before. What's happening here is you actually have 2 elements that are turned off while 2 other elements are actually being engaged. So we have 2 things coming off and 2 coming on. It's pretty crucial that the clutch pack assemblies the end plates are correct, and solenoids and valve bodies all working properly. So to synchronize this clutch-to-clutch setup, it takes the computer about 40 to 70 milliseconds to do that. And that's supposed to obviously produce a nice smooth shift with no bind-ups or flares. Now, if the underdrive compounder, for whatever reason, were to shift too early, especially like I was saying before, issues with clutch end play, you can end up with a shudder or a harsh shift. So you want to make sure that when we assemble this, that we pay close attention to the clutch pack end plays. If it were to shift too late, you actually may feel a double bump shift or a tie-up during the shifts. Now, to avoid, like we were saying before, to avoid that double swap shift on the 6-4 downshift, they use that 4th gear prime ratio, and that only requires turning off the overdrive clutch while we're bringing on the underdrive clutch. So we only have two components to worry about there rather than a double swap like on the other shifts. Now here's the application chart. Obviously this unit does have a Sprag, which is really good for non-synchronous clutch apply and release. The thing that I've noticed too is when you talk about other transmissions that don't have Sprags in them, the ZF 6-speeds, you'll notice that unit doesn't have a Sprag, and it always seems to be a complaint of 2-1 downshift clunks. Now I know there's been plenty of updates to the computer to try to help prevent that. It doesn't seem to really get rid of the problem. Now the GM6L80 is very similar to the ZF6, except they do use a Sprag there, and we don't seem to have that same complaint when when we're dealing with a 6L80. Now what I have here in the red boxes, as you can see over here on the left, these are the same ratios that you'll find in a 41 TE. Now here we have 6th gear, and it's still the final ratio in 6 is still the same as a 41 TE. And there's our 4th gear prime right there. Let's talk a little bit about power flow. Here we have the 62 TE in reverse. We have the reverse clutches driving. This is the same reverse input clutch that you would find on a 41 TE because we're still in that input drum assembly. The low reverse clutch is holding. Same thing on a 41 TE. Now in the compounder assembly, we actually have the low clutch holding. So that's reversed on a 62 TE. As we go to the first gear, you'll see that the underdrive clutch is driving, same as we had on the 41. Low reverse clutch is holding still. And now we have the low clutch holding in the coast. And that's in the compounder assembly. Once we get to the second gear, underdrive clutch is still driving, the low reverse clutch is still holding. Now we changed the compounder assembly from underdriven to direct. We have the direct clutch actually driving now in the compounder assembly. When we go to third gear, we now change. We still have the underdrive clutch driving, but now the 2/4 clutch is holding. Now 2/4 is a brake clutch, so that's now holding. Now the low clutch is still holding on the compounder, but now we have the overrun clutch holding. So that's third gear. When we go to fourth gear upshift, this is actually 4th prime. So in 4th prime, if we did a 6/4 downshift, we'd have the underdrive clutch holding, the 2/4 brake holding, and the direct clutch driving. 4th gear upshift, the normal overdrive position, underdrive clutch and overdrive clutch are driving, and that's in the main case area, and the low clutch is holding, and the overrun clutch is holding in the compounder assembly. We go to 5th. We still have the overdrive and underdrive driving in the main case, and then now we have the direct clutch driving in 5th gear in the compounder assembly. Last gear, 6th gear, overdrive clutch. Now the 2/4 clutch comes back on, the brake clutch, which is holding, and the direct clutch is driving. So there you have it. That's the power flow from reverse and from first gear all the way to 6, including 4th prime. So that's all 7 forward gears. Now to remove the compounder, one of the first things you want to do is you remove the valve body and take these tubes out. If you try to take the compounder assembly off without removing these tubes, obviously you can see that the tubes are going to go through the case, and they're actually going to go into the ply hole, feed holes here in the compounder assembly. It's kind of a good habit to get into. I've always done that in the past on a transmission that I've never taken apart before. I always like to take the valve body off, make sure there's nothing underneath that's going to prevent me from removing the pump, or in this particular case, the final drive area. So one of the things I want to mention here is you take the snap ring out, once you've removed the tubes, you don't have to take all of these bolts out of the compounder assembly. Now here's the reason why. If you have a tool, I'm showing you the OE tool here, and I even give you the part number for it. It's not necessary that you buy the OE tool, but you're obviously going to want to get some type of, make up some kind of an adapter so that'll thread into the holes that we removed for the tool. Now, this slide hammer makes this really easy to pull this assembly out. A lot of guys in the field that tried doing it without a slide hammer, they tell you, I'll tell you, it's pretty difficult. It doesn't take much to get that whole compound assembly to actually get stuck in there and cock a little bit. So as you can see, it's pretty heavy, so as you're taking it out, you want to support the weight and just lightly tap it all the way out of the case. And in the compound assembly, this is some of the main components that you're going to see. Like I mentioned before, we have a planetary setup in there now. You have the direct clutch here in the upper right, and there's your sprag assembly in the bottom left, and the low clutch there in the bottom right. So that's the main components of the compounder assembly. Now to take this apart, we're going to remove the planetary gear set first. We're going to take the output hub off. Once we do that, we get the planetary and everything out of the way. You want to make sure that you don't lose this adjustable shim right here. Okay? That sits right on between the sun gear and the actual planet itself. So we want to lose that during disassembly. Now, after we get the planetary off and we have our shim out of the way, you're going to need a couple of small picks to go in and to remove this retainer clip. Now, this retainer clip has 3 tabs on it that face down. You can see that right here at the bottom diagram. So we have to take that out next. After we take that out, you'll see that there's this plastic cage bearing, needle bearing here. You can take it out before to prevent any damage if removing the parts with the bearing still on there. You want to be careful with that. Like I said, that is plastic. If you prefer to leave it on, that's fine, but you want to take it off so that we can look underneath where the bearing rides to make sure there's no damage to the shaft where the bearings are riding on it. So either way, you should take that off and check for any wear or damage. Now, once we get that out of the way, we can take the direct clutch hub off of the low clutch hub right there. Now, once we get the direct clutch off, we want to disassemble it. There's a tapered snap ring, as you can see right here, and that is it's a bevel type snap ring. We want to have the dish facing up, just like we would on most of the cushion plates that we see in other transmissions. So the dish faces up on that. Then you'll find a couple of bearings in there, and first thing you're going to notice is the clutches in this assembly are single-sided clutches. Once you've taken the assembly apart, obviously just reverse the procedure going back. But we're showing you here the actual OE tool that Miller provides to help compress the spring. You can use anything that you have in the shop that'll work just like that. You don't have to go out and buy the actual OE tools for this transmission. Now, to check the end plane of the direct clutch, you can see here that we have it sitting on top of the low clutch hub, the low clutch assembly rather, and we're blowing through the feed hole. Now, notice they're putting some rags here. You either use some rags or wood. What you don't want to do is distort this area at all in any way. Like I was saying before, removing this thing, the clearance is pretty tight. So if we distort that or nick that in any way, it's going to be a real problem going back into the transmission case itself. Now, I like to air check with 30 psi. Sometimes you can overcome a leak that you won't even hear it when you're using regular full shop air. So I actually put a paint regulator on my blow gun on the back of it so I can regulate the air pressure down. So it's always a good idea to check with air check with 30 psi. The clutch clearance on this clutch pack is 37 to 56 thousandths. Now, when we take the low clutch assembly apart, again, I'm showing the OE tool here to compress the spring. You can use whatever you have in the shop that works fine for you. The clutches in this drum are normal clutches, double-sided clutches. And you have the Miller tool number if you do want to purchase that tool. Same thing here, we're using 30 psi of air pressure to check the clearance on this clutch. And the clearance should be like 18 to 29 thousandths. Let's talk a little bit about the Sprague. One of the important things that I want to mention is you notice this blind spot here, this missing spline, and you can see the lube hole there. We want to make sure that we align that up with this slot. That's important to, we want to make sure that the lube oil is getting down into the Sprague assembly itself. Now once the Sprague's on there, obviously if you hold the inside and you turn the outer race, it should go counterclockwise. And there's also an ID groove here, and that faces up when it's installed correctly. So just like the general rule on most ID marks, obviously you want to be able to see the ID marks as you're assembling something. So the ID groove, it should be facing up. The scarf cut sealing rings that you find on the shaft itself, nothing new here. The only thing I wanted to mention is a lot of guys like to reuse the OE rings on a lot of transmissions they're working with, and that's fine. I would still take them off the shaft to make sure that I don't have any problems with the groove itself, that it's not distorted or worn in any way that's going to prevent the ring from sealing. Now, one of the other things I'd like to make sure is that my clearance between the ring and the actual groove shouldn't be more than 5 thousandths of an inch. Some factory manuals may mention that you can go as high as 8 thousandths. I'm more comfortable keeping everything to either 5 thousandths or less. One of the things I do want to mention, when you do take these rings off, try not to distort them too much. Just be kind of gentle taking them off, and then put them down in the bores and make sure that they're going to fit tight in the bore, and we don't have a real big gap here where the scarf cut is located. This is a real common problem that we hear at the Tech Minor, we see in these transmissions all the time. And again, some of these pistons, they may air check well, and they may not obviously be split or cut as bad as this one is, but I've seen some that had some small cuts in them, and we're air checking a cold transmission sitting on the bench. It's going to react quite different once this piston gets hot. If it has a small split in it that you don't see, and then once it expands, that's when the leak's really going to show up in the transmission. So, to me, like any lip seal, if this was an aluminum piston or a steel piston had a lip seal on it, obviously I'd want to change it during rebuild. So I feel the same way about molded pistons. It's just another lip seal that should be changed during rebuild. As you check out the torque converter here, it looks kind of funny that the 62 TE is got a much smaller converter. It's called the squish design. They're trying to make these transmissions fit in smaller vehicles, less weight, save fuel. So now we have this converter that's actually looks squished, and in this diagram, you'll see exactly what I'm talking about. On the earlier, or on the 41 TEs rather, the converter is perfectly round. So now the engineers have to try to come up with a way of making this squish design. I'm sure it was not easy for them to do it. So they refer to that as an elliptical torus versus a round torus. Same thing with the pump. The pump is a squish design also. You can see it's much smaller. Again, on the ID marks here, we're looking at the dots that are on the 62 TE pump gears. Those have to face up. If you're working on a 41T, you won't find any ID marks, but what you do have to take a look at is one side of the pump gear itself, on both of them actually, will be a chamfer that's a much greater on one side than the other. Now that chamfer is not your ID mark. That chamfer actually has to face down because they want to hold lube in that pocket for the pump gears. So the chamfer side, the much greater chamfer side, has to face down. So make sure you do that on that unit. Also in the handout material, you'll find all the clearances to check the pump gears. And it's pretty straightforward. Although I noticed, sorry about that. I noticed that a lot of Chrysler pumps, especially like in the RVs and the earlier 3-speed stuff, they seem to be kind of sloppy compared to most of the transmissions that we deal with. The coolant bypass valve, a lot of times this is overlooked. Some techs don't even take it out of the case. It's something that really should be looked at. Obviously, it goes in with the O-ring first, and then you can see the stem of the bypass valve sticking out there. We want to take this out, and if we're going to reuse it, we want to change that ring. We don't want any kind of a cross leak here, because basically what happens is this valve will allow the transmission fluid to go right back into the pan to get the transmission to warm up quicker. Obviously, if it's stuck and you pull off the coolant lines, and if you have oil coming out of both coolant lines, that valve is definitely stuck. Now, with oil coming out of both coolant lines, obviously when they meet at the radiator, we don't have any flow at that point. We have plenty of lube oil, it's just not going to get cooled. And trust me, I've had one of these stick on me at my shop, and I don't think I went a whole block on a road test when smoke started coming out of the filler tube. So make sure that we either replace this or at least go ahead and check it and make sure that everything's good. Most common failure, guys always ask me all the time on different transmissions, what fails the most? Well, you're looking at it. This is the most common failure that we find, and that's in the low clutch sealing ring grooves. These here, as you can see, look fine. Now, this is normal. This is the step ring that you'll find in here, and you'll probably find about 5 thousandths clearance or less right in this area. Now, if you look at this piece, it's nice and shiny. It looks like steel. Well, it's not. It's actually aluminum, and that's the problem. These ring lands wear out pretty bad. Now here's another picture of one that's worn pretty bad. I mean, you can see the tremendous amount of clearance here in the top ring, and quite a bit also on the bottom one. Now, this is catastrophic. This is where the ring land basically wore right off. You may not even find the ring. I've actually had guys call me and say, hey, is this supposed to have one sealing ring on this drum, or should it have 2? Because it almost looks like it's perfectly machined that way. Now, I talked to a buddy of mine at the dealership here in Florida that works on these a lot, and I asked him, I said, what's the failure rate on this compounder assembly? Because we were just getting flooded at the tech line with these units coming in, seeing this failure, and he said 100%. Well, when I started to laugh, he said he wasn't making a joke. So I have to tend to believe him, because he works on them all the time. Now, in the aftermarket, you can actually purchase this drum where this has been removed, and they actually insert a steel ring tower. So they are available in steel in the aftermarket. And obviously, you can use the regular OE step type rings that come with it. Now, what I did find out the other day was, that it's not in your handout, but you can do another print screen shot of this slide if you'd like. Sometime during the mid to late 2013 model year, last year, the OE came out with a new low clutch drum. And what it has is anti-rotating rings similar to what you would find like on a 4T65, which to me makes quite a bit of sense. So now that we don't have that ring rotating in there, it should save of the problem of having those ringlands wear out. The only, obviously, this is a new update, a new fix, so I don't know what the new rings will be like as far as wearing the drum on the top that rides on it. So that's actually, it's all stationary, so it shouldn't be a problem there either. There's the part number, but the actual old part number will supersede to the new part number. But like I said, if you want to write that down or to actually take another print screenshot, you can have that there. This seems like a new failure that we're starting to see more and more in the tech line. Guys will call in and they'll say that the, oh, I'm sorry, I kind of missed a question here. There's a question on Prime always on a downshift from Tony. Yeah, Tony, from what I understand of the way the OE explains it is on a 6-4 downshift, that's when fourth prime is used. Hope that answers your question. Sorry I didn't catch it earlier. Now, again, getting back to these direct clutch housing, if yours comes in and you have these codes, PO792, PO735, or you have issues with no line rise and it's got a real severe slip on the 1-2 shift, more than likely you'll take this apart and you'll find the snap spring is dislodged and the clutch pack has come up high enough where it's probably cut the seal. Again, if this comes into your shop like this, some guys have attempted putting in a heavier snap ring to try to keep it from coming loose, and sometimes it works and sometimes it doesn't. The bottom line here is if it comes in this way, you're going to want to just change the drum. I don't know of any updated part numbers at this time for a new drum. Most common code that we get on the tech line is the P2764 TCC stuck on. This one's pretty easy fix. You can just basically take the side cover off, one bolt, take the TCC solenoid out. You have the part numbers in your handout material, and just replace that one solenoid. This is the most common build error. This is something that I've actually had several calls on this, and it may not be the first time we rebuilt it, but most of the time it's the first time rebuild, and you'll make the mistake of taking this tube seal that you see here and flipping it upside down. This is the correct way that it goes in. Now that's the 2-4 clutch speed that we're looking at. Now, the first thing that will happen after rebuild is you'll get no fourth or sixth, and then once it goes to failsafe, which is third gear, you won't have third either. So this thing will slip like crazy when it goes to third gear, failsafe. Now, the problem is, as you can see, the oil comes down this worm track here, and it has to get down inside the tube through the slot to feed the clutch. So don't make that mistake of putting that in upside down. And that's about does it for today's webinar. Again, I want to thank Seal Aftermarket Products for providing this webinar for free to everyone, to members and non-members. The next webinar we're going to have will be on September 2nd at the same time. Actually, no, yours I believe will be on September 3rd. Yeah, yours will be on September 3rd, 2 weeks from now.